Welcome to our latest video on the topic of oxidation numbers. This video is suitable for both AS and A-level students. By the end of this video lesson, you should be able to apply the rules for assigning oxidation numbers in order to work out the oxidation number of an element in a compound or ion from its formula. You should also be able to explain the meaning of the terms oxidation and reduction and be able to identify when each is taking place in a chemical or ionic equation. And finally, you should be able to understand the meaning of the terms oxidizing agent and reducing agent and be able to identify them in chemical reactions. Now at GCSE, we learnt that ionic compounds consist of oppositely charged ions held together in a giant structure called a crystal lattice, and the chemical formula of an ionic compound depends on the charges of these ions. Now, the table on this slide is the same table that you're given at GCSE, and it shows positive ions and negative ions, and at GCSE you are expected to be able to use this table to work out the chemical formula of various compounds. So for example, if you are asked to work out the chemical formula of sodium oxide, you would use this table of ions to work out the formula. So for example, sodium consists of Na plus ions, the oxide ion is an O2 minus ion, and when you're writing the formula of a compound, the pluses and minuses must cancel out, so you need two Na pluses to cancel out an O2 minus ion, and a common method is just to swap the charges over. So I swap the 1 plus and the 2 minus over and I get the formula Na2O. And if I was working out the formula for magnesium chloride, magnesium consists of Mg2 plus ions, chloride ions are Cl minus ions. I can either swap the charges over, so I can swap the 2 from the magnesium and the 1 from the chloride ion, and then the formula is MgCl2, or I just look at this formula and say how many Cl minus ions do I need to cancel out the 2 plus charge? 2, and that's why the formula is MgCl2. Now, as we've seen from these two examples, the ratio of elements in a compound depends on the charges of these ions. And we can think of this as combining powers. Now, a method of expressing the combining power of elements when forming compounds is to use the term oxidation number. Now, the oxidation number is the number of electrons that need to be added or taken away from an element to make it neutral. So for example, if we have the compound calcium chloride, CaCl2, this is made up of Ca2 plus ions, calcium ions. It's also made up of Cl minus ions, chloride ions. And this Ca2 plus ion in calcium chloride needs 2 electrons to make it a neutral calcium atom. Therefore, we say that the oxidation number of calcium in this compound would be +2. Now, the oxidation number has the same value as the charge of the ion. However, when we write the oxidation number, we write the positive charge before the number when we write in oxidation numbers. So it's +2 instead of 2 plus. Now the +2 means that we just need to add 2 electrons to this calcium 2 plus ion to make the neutral atom. Now if we look at another example, so I'm going to look at the aluminium ion, which is Al3 plus. The oxidation number for aluminium is +3 because an Al3 plus ion needs to gain 3 electrons to form the neutral aluminium atom. Now once again, when writing the oxidation number, the value of the oxidation number is the same as the charge. except that we write the positive charge first. So instead of it being Al3+, the oxidation number for the Al3+ ion is +3. I put the positive charge first. So now let's look at negative ions such as the oxide ion. Now if we look at the compound magnesium oxide, that's made up of magnesium ions, Mg2+, and oxide ions, which are O2- ions. Now the O2- ion needs to lose 2 electrons to make it a neutral oxygen atom. Now as it needs to lose 2 electrons to make it a neutral atom, the oxidation number is -2. Now notice once again the oxidation number has the same value as the charge, but all we have to remember is that the sign, the negative sign in this case, goes before the number when writing oxidation numbers. So it might be an O2- ion, but the oxidation number is written as -2 because it needs to lose 2 electrons to form the neutral atom. Now when working out oxidation numbers, there are a number of rules that we have to consider. So let's look at these rules in turn. So the first rule that you have to remember is that the oxidation number of an uncombined element is 0. So for example, aluminium metal, copper metal, oxygen gas, they're all elements and they have oxidation numbers of 0. Now group 1 metals such as sodium and potassium have an oxidation number of +1, while group 2 metals such as magnesium and calcium have an oxidation number of +2. Now this should be no real surprise because you should be familiar with the fact that sodium ions are Na+, potassium ions are K+, magnesium ions are Mg2+, and calcium ions are Ca2+. And we've already just seen that the oxidation number is the same value as the charge, except that we have to remember to put the sign before the number when writing oxidation numbers. So for example, if we have a sodium ion, Na+, the oxidation number is +1. If we have a magnesium ion, Mg2+, the oxidation number is +2. Now the next rule that we have to remember is that the oxidation number of oxygen in compounds is usually -2. You should be familiar with the O2- ion. Now the exception to this is with peroxides and when the oxygen is bonded to fluorine. So for example, in hydrogen peroxide, H2O2, oxygen has an oxidation number of -1, while in F2O, oxygen has another unusual oxidation number of +2. Now these are exceptions to the rule because in the majority of cases oxygen has a -2 oxidation state when in a compound. Another rule you should be familiar with is that the oxidation number of hydrogen is +1 in a compound. Now the only exception to this is with metal hydrides such as sodium hydride, where hydrogen has an oxidation number of -1. Now the next rule you should be familiar with is that the sum of the oxidation numbers in a compound is equal to 0. For example, if we take the compound aluminium oxide, Al2O3, aluminium has an oxidation number of +3 here, and oxygen in the form of the oxide ion has an oxidation number of -2. So the 2 aluminiums have a total oxidation number of +6, while the 3 oxide ions have a total oxidation number of -6. The +6 from the aluminiums and the -6 from the oxygens cancel out, and therefore we have a combined oxidation number of 0. Now in all compounds, the sum of the oxidation numbers will be 0. Now the last 2 rules you need to be familiar with when assigning oxidation numbers are as follows. In an ion, the sum of the oxidation numbers equal the overall charge. So for example, In the sulfate ion, which is SO4 2-, the sum of the oxidation numbers are equal to -2 because the charge of the ion is 2-. So this is because 4 oxygens have a total oxidation number of -8, 4 times -2, and sulfur has an oxidation number of +6 in this ion. So therefore the sum of the oxidation numbers +6 plus -8 equals -2, the charge on the ion. Now the last rule you have to remember is that in chemical compounds and ions, the most electronegative atom is assigned the negative oxidation number. So for example, in F2O, fluorine is more electronegative than oxygen, and therefore it's fluorine that has a -1 oxidation number here. So with 2 fluorine atoms here, it has a total of -2 for its oxidation number. So therefore the oxygen in F2O must have the unusual oxidation number of +2. So now let's test your understanding of this with some practice questions. So here's the first practice question we like to have a go at. So read through the question, pause the video, have a go at the question, and then we'll go through the answers. So now let's go through the answers to question 1. So in question 1A, you're asked to find the oxidation number of magnesium in MgCl2. Well, chlorine has an oxidation number of -1, and we have 2 chlorines, so the total negative oxidation number is -2. Magnesium therefore must have an oxidation number of +2 because the sum of the oxidation numbers in a compound must equal 0. +2 added to -2 is equal to 0. 1 mark for that. Now for the next one, you're asked to find the oxidation number of chromium in Na2CrO4. So oxygen's -2, sodium's +1. So 4 oxygens have a total minus oxidation number of -8. Sodium is +1, so 2 sodiums are +2. So therefore the chromium must be +6 if the sum of the oxidation numbers are going to be equal to 0. 1 mark for that. Now for C, we have manganese in MnO2. Now oxygen has an oxidation number of -2. There are 2 of them, so that adds up to -4. So the manganese must be +4 in order for the sum of the oxidation numbers to be equal to 0. And our last one, we have ClO3 1-. So oxygen has an oxidation number of -2 here. We have 3 of them, so therefore we have a total of -6 for the oxygens. Now the iron has an overall charge of -1, so the sum of the oxidation numbers has to equal -1. So therefore the chlorine must be +5 oxidation number, because +5 added to -6 equals -1. And another way of looking at this is you have to cancel all the minuses but 1 because it's got a -1 charge. So therefore you need +5. Now this question is worth a total of 4 marks. There's 1 for each correct oxidation number. So now have a go at our second practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go through the answers to question 2. So in 2A, you're asked to find the oxidation number of nitrogen in N2O. Now here, oxygen is the more electronegative element, so it has the minus oxidation number. So oxygen's -2 here. So therefore N2 must add up to +2, because remember the sum of the oxidation numbers have to equal 0 in a compound. So each nitrogen has a +1 oxidation number. Now in B, we have IO3 1-. Now once again, oxygen is the more electronegative atom, so it has an oxidation number of -2. It has the negative oxidation number. So 3 oxygens is -6. The overall charge on the ion is -1. So the iodine must be +5 because we have to cancel all the minuses but 1 here. And +5 added to -6 equals -1. Now for C, we have to find the oxidation number of sulfur in S2O32-, the oxygen -2, so we have 3 of them, so that has a total oxidation number of -6. The overall charge on the ion is 2-, so therefore S2 must be equal to +4, and each sulfur must have an oxidation number of +2. Now in our last question, we have manganese in KMnO4. The oxygen has an oxidation number of -2. There are 4 of them, so we have a total oxidation number of -8 here. Now the potassium has an oxidation number of +1, so therefore the manganese must be +7 oxidation number, because the sum of the oxidation numbers must add up to 0 in a compound. So +8 added to -8 equals 0. Now each oxidation number correct gets you 1 mark here. So now that we understand the term oxidation number and how to calculate the oxidation number, we're now going to look at the meaning of the terms oxidation and reduction. At GCSE, we mainly use the term oxidation to describe a gain of oxygen. However, at AS and A level, the term oxidation is nearly always used to describe a loss of electrons. Now, oxidation leads to an increase in the oxidation number. So in other words, if a species starts out at one oxidation state and ends up at a higher oxidation state, it is said to have undergone oxidation. Now at GCSE, you would have mainly used the term reduction to describe reactions where there's been a loss of oxygen or a gain of hydrogen. However, reduction can be defined as a gain of electrons, which leads to a decrease in oxidation number. So any species whose oxidation number is lower during the course of a reaction has undergone reduction. So now let's look at a very simple chemical equation. So here we have sodium reacting with chlorine to form sodium chloride. And the chemical equation is 2Na plus Cl2 goes to form 2NaCl. Now this reaction has both reduction and oxidation taking place and can be described as a redox reaction. Now this is because the sodium, when it's an element, has a 0 oxidation state. And when the sodium is converted to sodium chloride, the sodium has a +1 oxidation state. In other words, we've gone from 0 to +1. There's been an increase in oxidation number, and the sodium is described as being oxidized. It's lost electrons. Now, if the sodium has lost electrons, the question is, where have these electrons gone? Well, they've gone to the chlorine. And we know this because chlorine is an element and has a 0 oxidation number. And when we convert chlorine to sodium chloride, the oxidation number of the chlorine in sodium chloride is -1. So here we have 0 oxidation number changing to -1. The oxidation number has been lowered, is being reduced, and therefore reduction has taken place. So the chlorine has been reduced to chloride ions. Now reduction is a gain of electrons. So chlorine here has gained electrons to form chloride ions. Now to help you remember this, you should remember oil rig. Oxidation is a loss of electrons, reduction is a gain of electrons. So now let's look at the meaning of the terms oxidizing agent and reducing agent. Now we've just seen that oxidation is used to describe a gain of oxygen or a loss of electrons. And at AS and A level, you should really be thinking of oxidation as a loss of electrons. Now an oxidizing agent is therefore a substance that causes another substance to gain oxygen or lose electrons. And a good oxidizing agent is a substance that's easily reduced. Now if we look at the reaction we've just studied, we have sodium metal reacting with chlorine to form sodium chloride. And sodium is 0 oxidation state as it's an element, and when it changes to sodium chloride it's +1 oxidation state. That is a loss of 1 electron. Sodium going from 0 to +1 is oxidation. It's a loss of 1 electron, and that electron goes to a chlorine which has 7 electrons in its outer shell and easily gains that electron. So the oxidation number of chlorine goes from 0 to -1. That is reduction. The reason that chlorine is a good oxidizing agent is because it gains an electron easily. So an oxidizing agent is a substance that causes another to lose electrons. Now at GCSE, we would describe reduction as a loss of oxygen or a gain of hydrogen. However, at AS and A level, we really need to think of reduction as a gain of electrons. So a reducing agent is therefore a substance that causes another substance to lose oxygen, gain hydrogen, and most importantly, gain electrons. Now, substances that make good reducing agents are easily oxidized. So if we look at the following equation, we have iron oxide reacting with carbon monoxide to form iron and carbon dioxide. Now at GCSE, we'd think of carbon monoxide as a good reducing agent here because it steals the oxygen from iron oxide. Now at AS and A level, we really need to think of reducing agents as substances that cause other substances to gain electrons. Now carbon monoxide acts as a reducing agent here because it causes the iron, which is a +3 oxidation state in iron oxide, to change to 0 oxidation state in iron metal. Now the reason that this reaction works is because in carbon monoxide the carbon is the unstable +2 oxidation state of carbon, and therefore when the +2 oxidation state of carbon in carbon monoxide changes to the more common +4 oxidation state in carbon dioxide, electrons have been lost. The carbon has been oxidized. So once again here we have reduction and oxidation taking place. That's why this equation is a redox equation. The iron in iron oxide is in the +3 oxidation state, and when this changes to iron metal, reduction takes place. There is a gain of electrons. These electrons have come from the carbon monoxide because the +2 oxidation state of carbon in carbon monoxide changes to the +4 oxidation state in carbon dioxide. Oxidation takes place. So the carbon monoxide is responsible for losing electrons, and these go to the +3 oxidation state of iron to turn it to iron metal. So now let's test your understanding of this with some practice questions. Once again, read through the questions, pause the video, have a go at them, and then we'll go through the answers. So now let's go for the answers to questions 1 and 2. So these questions are asking you to state whether elements have been oxidized or reduced here. So let's start with CrO42-. Oxygen is a -2 oxidation state. So I've got 4 oxygens, so that's a total of -8. The iron has a 2- charge, so therefore chromium must be +6 oxidation state here. Now in the equation it changes to the +3 oxidation state, So the oxidation number has gone down, it's been reduced, so therefore reduction has taken place and the chromium has been reduced. 1 mark for that. Now in question 2, we have MnO3. Oxygen is once again -2 oxidation state. I've got 3 of them, so it's -6 in total here. So the manganese must be +6, because remember, compounds have 0 oxidation state. In MnO2, we have O2-, so there's 2 of them, so it's -4. So therefore the manganese is a +4 oxidation state. So therefore, during this equation, manganese has gone from +6 to +4. The oxidation state has gone down, so it's been reduced. So therefore, reduction has taken place and the manganese has been reduced. 1 mark for both of these. So now have a go at the next practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answer to question 3. So we're asked whether sulfur in the following equation has been oxidized or reduced. So if we look at this, we have SO3 2-, and oxygen is a -2 oxidation state. We have 3 oxygens, so that would be -6 here. The iron has a 2- charge, so I need to cancel all the minuses but 2. So the sulfur is +4 oxidation state. And in SO4 2-, the oxygen is once again -2, so I have 4 of them, so that's a total of -8. Once again, the iron has a 2- charge, so I need to cancel all the minuses but 2, so the charge on the sulfur is +6. So during this reaction, sulfur's oxidation state goes from +4 to +6. The oxidation number has increased, so therefore oxidation has taken place and therefore sulfur has been oxidized. 1 mark if you recognize this. So here's our next practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So in question 4, it says, examine the change in oxidation state of the named element in each of the following, stating whether oxidation or reduction has taken place. So in this first equation, we're going to look at what happens to iron. Now, the chlorine is a -1 oxidation state, so the Cl3 is -3, so therefore each iron is +3 oxidation state. The fact that it's 2 FeCl3 doesn't matter at all. We just need to look at the formula of each compound here. Now, in FeCl2, the iron is +2 oxidation state. So therefore, the iron has gone from +3 to +2. The oxidation number has decreased, it's been reduced, so therefore reduction has taken place. Now, in the second part of this question, we have PbO2, and oxygen is a -2 oxidation state. So therefore there's -4 for the 2 oxygens, so the Pb, the lead, is +4, and it changes to PbCl2, so the 2 chlorines are -2, and therefore the Pb is +2 oxidation state. So therefore the lead, the Pb, has changed from +4 to +2, the oxidation number has decreased, it's been reduced, and reduction has taken place. So in both these questions, there's 1 mark if you correctly identified reduction is taking place, and 1 mark if you correctly identified the changes in oxidation state each time. So here's our last practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So in question 5, you're first asked to write a chemical equation to describe the reaction between chlorine and a solution of potassium bromide. So the equation would be Cl2 plus 2 KBr goes to Br2 plus 2 KCl. 1 mark if you had the correct chemical equation. Now for part B, you asked to explain with reference to oxidation numbers why chlorine is acting as an oxidizing agent in this reaction. So when answering this question, I recommend that you work out the oxidation numbers for each of the elements here in each of the formula. So for example, chlorine is 0 oxidation state when it's Cl2. In KBr, potassium is +1 and bromine is -1. And in the products, bromine is 0 oxidation state when it's an element. And in KCl, the potassium is +1 and the chlorine is -1. So the reason that chlorine is acting as an oxidizing agent here is because it's causing Br- ions to each lose an electron to form bromine atoms and then bromine molecules. So your two Br- ions in 2KBr are both losing an electron each to form Br2. So the idea that it's causing Br- ions to lose electrons gets you a mark. And the second mark is if you make reference to the oxidation numbers going from -1 in Br- to 0 in Br2. And this increase in oxidation number is evidence that oxidation is taking place. So in summary, this question is worth 2 marks. So you get 1 mark for the idea that chlorine causes Br- ions to lose electrons to form bromine, and you get the second mark for making reference to the oxidation number of Br going from -1 to 0, which shows you that oxidation is taking place. So that concludes this video lesson. So after watching this video, you should now be able to apply the rules for assigning oxidation numbers in order to work out the oxidation number of an element in a compound or ion from its formula. You should also be able to explain the meaning of the terms oxidation and reduction and be able to identify when each is taking place in a chemical or ionic equation. And finally, you should understand the meaning of the terms oxidizing agent and reducing agent and be able to identify them in chemical reactions. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.